Are you there, Ajad? చంద్రశేఖర్ గారు
సార్
ఉన్నారా? ఎవరున్నారండి కోహోస్ట్ ఇవాళ?
ఉన్నాను సార్, కోహోస్ట్ కింద ఉన్నాను కదా.
ఓకే ఓకే, అంటే వాళ్ళ పార్టిసిపేట్ స్టూడెంట్స్ వస్తున్నారు వాళ్ళంతటి వాళ్ళే. అంటే సిఆర్ రెస్పాండ్ అవ్వలేదు, క్లాస్ స్టార్ట్ అయ్యి వచ్చా లేదా అని, అందుకే అడిగాను. ఓకేనండి ఓకేనండి
ఓకే సార్.
ఓకే ఓకే. Today we will discuss with the automatic lathes. So in spite of giving 10 minutes between the classes, people are not joining. So only 40 people have joined. I'll start the class, and those who are joining late will miss the introduction of automatic lathes. So what is the automatic lathes, and what do you mean by automation exactly? So automation is an extension of mechanization. So whatever mechanization is there in the ordinary center lathe or engine lathe, but here whatever manual things are there in the center lathe or engine lathe, here automation and automatic lathes, it is an extension of automation. So we'll try to provide some like camshaft drives, and we try to provide the particular automatic feeding mechanism, automatic speed mechanism, the speed control, depending upon the type of operation, or we'll try to select the speed, but sometimes depending upon the programming, as far as the CNC trainer lathe is concerned, according to the particular operation, the speed and feed will be automatically controlled with the help of other the particular whatever controls, we can say the control systems. So just or like we can say the servo controls. So here without the help of the human element, the automatic lathes can be run or can be used in the machine shop. So here we'll first go for the, here features are not there, but I'll try to speak on my own. So just try to say what are the features of automatic lathes. What are the features of automatic lathes? So in this automatic lathes, this no human intervention. So you can say we don't have to depend on the operator. We don't have to depend on the operator. So what is the first feature? The machine, once the machine is set up in automatic lathes, all the operations related to the manufacturing cycle, and also the loading of the jobs or work pieces, the raw work pieces, or we can say in some cases blanks, or the different words, not in some cases, different words, keywords we'll try to use. Loading and unloading of the machine parts, loading of the job raw blanks or unloading of the machine parts are performed by the machine itself. So that is a automatic the particular, you can say, automatic loading and unloading. So next, we don't have to, the overall time of the job when compared to the other lathes, center lathe or engine lathe or the other lathes, though we can say turret lathe or capsule lathe, but the semi-automatic, but if we want to make fully automatic also, but when we compare to the other lathes, the overall time for the job is quite less. So here the accuracy also is high, accuracy produced of the machine parts, the dimension sake or the particular geometric features, the two types of tolerances, dimensional tolerance and geometric tolerance. So here the efficiency of the machine is more. The efficiency of the machine is more. And all that particular things, because why we are speaking of the automatic lathes, all the operations go automatically, as the name implies. So we'll discuss one by one all this, the features, the operations, and the components. So first of all, we'll try to go for the diagrams in the bottom. So highly automated machine tools here, particularly on the lathe family, are called automatics or semi-automatics. So in semi-automatic lathes, sometimes the human intervention is there, and in automation plays an important role in mass production. That's why we are opting for the automatic lathes. So these automatic machines are designed to perform the specific jobs only, specific diagrams or specific designs as far as the R&D department is concerned. And they have minimum flexibility of the use in other works. In other works, we cannot use automatic machines. They are used for complex jobs. So this automatic or semi-automatic machines or the lathes are, they can perform a wide variety of operations like turning of cylindrical, tapered or formed surfaces, like facing, spot facing, drilling. All operations are performed by the machining center and turning centers also by writing the part programming, CNC part programming. Here we can suppose we have the competitive numerical control attached with the automatic machines. It's simply known as the numerical control machine. So all these are very important aspects you have to consider, and we have that other machining operations can also be performed on them using special attachments. So just try to see all this particular things, and this particular during the machining process, you can say cutting tools are mounted on the slides. So they move automatically according to whatever predefined schedules are there or predetermined schedules are there, and feeding rates are also the automatic feeding mechanism is there in the automatic lathe. So how you can achieve this particular automatic feeding? You can see in the particular figure, we'll just try to see this is achieved with the help of the cams. So that's why we'll try to just in one of the components of the single spindle automatic lathes or this automatic lathes, we have the camshaft drives, So all these are the things we can just have. So the particular whatever operations are required, so we just try to preset all the tools in the turret, hexagonal turret or the disc turret in the case of a automatic lathe or the turret lathe, and they are clamped in position during the machine setting. So all this we'll just try to discuss. Preset tools means what are the preset tools? Already I told you, we have to preset the tools for the tool offset. We have to go for the tool compensation or cutter radius compensation. So all this are there. So in order to obtain the dimensional tolerances, because we have for the batch production, all these are used for batch production. So the whatever the particular design, all the cutting tools are arranged in a machining sequence. So suppose one particular tool is going on is busy in the machining operations, unless and until that particular cutting tool is finished, and unless is finished, we'll just try to bring the particular tool T01 or T02 or something. We can accommodate as many as 14 tools in this direct. We'll just try to bring the particular tool to the home position and then place the other tool T02 in front of the job or workpiece. So in case of the automatics, you don't have to measure the dimensions of the work, because the particular all the cutting tools on the particular sides on the corresponding slides are automatically fed, and they are stopped by the preset positive stops, preset feeding stops, or preset mechanical stops, or we can say the feed trips. So all these are definite words we'll try to use in this particular the automatic lathes. Slowly we are going towards automation. What I mean to say, slowly we are going towards automation in manufacturing. Slowly we are taking the help of computers, that is computer aided manufacturing. So all these are definite things we'll just try to say. So for quick loading and unloading, already I told you, automatic loading and unloading of workpieces on the machine at the tailstock side, at the chuck side, or whatever fixtures you want to design. You'll just try to see in the unit 6 the fixtures, different types of fixtures like turning fixtures, milling fixtures, welding fixtures, all these are there. So they're designed, all these particular fixtures, they're designed either designed to operate electrically or having the electrical circuits hydraulically by using the hydraulic cylinders, or pneumatically by using the pneumatic cylinders. For this, we try to have the air compressor. So all these are very important things. So now we'll try to go for this particular diagram, for this schematic diagram of this automatic machines, or automatic cutting of machine, you can say. So we have the bar stock here, a lengthy bar stock. So we have the cam drums. Well, this cam drums, or whatever in some of the textbooks, they are known as camshaft drives. They control the bar feed and chucking. Chucking is very important because the particular rotation of the bar stock should be at a definite speed according to the particular operation. And here we have the cross slide. Here we have the longitudinal side, and we have the tool here for machining of the bar stock, and we have the cross slide feed cam. It's not the cams we can mount on the longitudinal slide, as well as the cross slide to control the here we have the cross slide feed cam, here we have the longitudinal feed cam drum. So all these are known as the camshaft drives. The camshaft drives are a combination of cross slide Okay, power has gone off. The Wi-Fi. Chandrasekhar garu.
సార్
Chandrasekhar garu.
సార్
అంటే వైఫై పోయింది, కరెంట్ పోయింది. ఇప్పుడు దీంట్లో కనెక్ట్ అయ్యాను మొబైల్ డేటాతో. ఇది కంటిన్యూ చేసేస్తాను.
ఓకే సార్,
వినిపిస్తుందో లేదో అడగండి.
వినిపిస్తుంది సార్.
ఓకే, స్క్రీన్ కనిపిస్తుంది కదా?
ఎస్ సార్, కనిపిస్తుంది సార్.
స్క్రీన్
ఓకే సార్, విజువల్ ఆడియో.
ఓకే రికార్డింగ్ రికార్డింగ్ కూడా చూడండి ఒకసారి, అవుతుందా లేదా?
అవుతుంది సార్.
రికార్డింగ్ పాస్ అవుతుందా? పాస్ అయిందేమో అనుకున్నాను. ఓకే సో విల్ జస్ట్ ట్రై టు సీ దిస్ పర్టికులర్ This is a typical setup of an automatic cutting off machine. Where we have left, we'll just try to see the camshaft drives will be consisting of the longitudinal slide feed cam drum. This will be feeding the particular the whatever shafts are there. That's why they're known as the camshaft drives. Different differential shafts are there, which will be operating at differential speeds or different speeds. That's why they're known as the differential speed camshaft drives. And here they have the cam drums also for the controlling the bar feed and checking. So all these are very important diagrams which you have to practice. So what is the final result of automation? Final result of automation is increased productivity. So whatever better utilization of resources, human resources or the machine resources, or the machine utilization is 100%, 100% or maybe more than that. We cannot give more marks or more percentage, more than 100%. So floor space area is also we can effectively use the floor space area also, and we have the reduced maintenance because we have all the particular particular control systems, servo motors, the position feedback, the position feedback of the tools. All this will just learn in computer aided manufacturing in the control system. Two types of control system are there: open loop control system and feedback control system. So control systems are nothing but simply we can say the particular thing. Just suppose I am a machine. Suppose I am the machine control unit and you are the machine. So we'll be having an effective communication between the machine control unit and the automatic machine or the semi-automatic machine or the numerical control machine. So all these are very important things. We'll just try to discuss. And I already told you, you don't have to go for particular accuracy dimensions, or you don't have to check in between. So that is very important. And the surface finish of the product also can be achieved. And we can go for economy also. It will improve the overall economy. So before going to this automatic and semi-automatic layers, so already you had an idea of what this automatic or automation is as far as the automatic and semi-automatic layers are concerned. So these are effective in both the work handling, automatic work part clamping, we say, or workpiece handling during metal cutting. And the metal cutting operations or machining operations are performed automatically. So this particular machines have the full automatic cycle or the machining cycle, and they are used to produce the same parts, same work pieces or duplicate parts, and no human intervention is there. So all these are there. So here all the operations starting from the feeding of the bar stock and clamping of the workpiece, automatic. Here it is automatic clamping. So all these are there are performed, or the required final shape and size we can achieve automatically. All these are very important. And how you can achieve automatically all these particular dimensions or the automatic feed and speed or whatever it is. These are achieved by using camshaft drives on the longitudinal slide and the cross slide, and the feed drums are there. So all these are there. We have the feed stop settings or the mechanical stops or the whatever actuating mechanisms or whatever actuating mechanisms. But here the actuating mechanisms are known as simply actuators. They may be hydraulic or pneumatic in nature. And we have the other mechanical movements of the machine. So all these particular automatic machines will comprise of numerical control machines, transfer machines, because transfer machines you cannot know now in computer aided manufacturing. The systems just know, but here we have the automatic bar machines, automatic linear bar stocks. Maybe you are having a hall in a homes, that but particular machine will be the length of the hall, or two bedrooms compressed together, like that. So all these are the examples of automatics. So what is the only operation that is done manually on these machines? Though he has told manually, but in some of the machines it is designed for automatic loading also. Sometimes in semi-automatics we go for loading of the bar stock or the jobs or individual castings or forged components or forged blanks. So in multi-spindle automatic lathes we have the chucking type and the we have the bar type and the chucking type. In the chucking type of machines we use the individual castings or large forged castings or forged blanks. So and the inspection of jobs we have to do manually, though we have the automatic gauging facilities and computer aided inspection and quality control. All this we'll try to do. So all this we'll try to have. Before going to the semi-automatic lathes, we'll try to have the components. Just we'll try to discuss the components because if the diagrams I'll just try to discuss that also. But the main parts, what are the main parts of a single spindle automatic lathes? You know, simply as far as a single simple center lathe or an engine lathe, we have the base, we have the bed, all these are very important things. We have the camshaft drives we have discussed now. We have the headstock at the left hand side, which are comprising of the speed controls, the gear mechanisms, the belt drives to control the speed of the spindle. All this are there. So we have the turret carriage. You know what is a turret? Already we have discussed in turret lathe. We have the carriage for that one. We have the bar feed mechanism. This bar feed mechanism is there in is not there in ordinary center lathe or engine lathe. We have only in the turret lathes and the automatic lathe machines, fully automatic, not in semi-automatic. So semi-automatic already we have discussed because the loading of the bar stock is made by the human operator or the operator. So we have the other drives like to control the shafts. They are known as the back shaft drives, and others are there because already we have discussed in the unit 1 the coolants or the cutting fluids or the lubrications. We have the lubrication units because they're very important to control the temperature of the workpieces, because the dimensions of the workpiece are disturbed or affected by the too much heating of the too much friction between the particular workpiece and the tool. So all these are very important parts of the single spindle automatic lathe. So now we'll just try to come to this semi-automatics. So semi-automatic, these are also the same. Like the lathe, we have they are also known as the turning machines, and mostly they are adapted to chuck type work. Only in semi-automatic machines we'll discuss about the bar type, but most of the particular machines or the semi-automatic lathes are of the chuck type. So what are the machining operations are there? All are done automatically, just the same way as we do in the fully automatic lathes. Already I told you the loading is done, loading of the blank or bar stock, and the removal of the particular finished workpiece from the chuck, from the 4-jaw independent chuck or the 3-jaw universal chuck will be done manually at the end of each machining cycle, you can say, or at the end of each operation. So all these are the particular things we try to do, and all this are done manually. We have to check the job size during the operation because they're not fully automatic, and unloading of the finished job is also done manually by the skilled operator or the semi-skilled operator. Every time don't try to use the skilled operator, because management will try to discuss, will try to just concentrate on the economics of the just like economics of machining, economics of the manpower also. They can train the ITI people or the particular polytechnic side, the programming, and try to make them, they'll send them for training for learning for operating the NC control machines or the fully automatic lathes. And here the semi-automatic machines are mostly preferred for the lot production. lot production work. No, maybe the not for batch production, mass production. So we have now, before going to the classification of the automatic lathes, how they are classified. How they are classified? They are classified according to the type of stock, type of bar stock or job. So all this we have to discuss. So all this we have to discuss. And the bar automatics are the produced components using bar, linear bar, slender bars. The bars are of thick or slender or thin. Slender or thin is one of the things. Long pipes we can use, we can go for the bar automatics, linear pipes used in plumbing operations, used in for water, not only for water, for to transport the oil and other fluids from one place to other. So all this, and we have the bar, apart from bar automatics, chucking machines. Chucking machines already we have been touching from now and then. These are machining separate blanks, this castings and forgings. So that's why this particular chucking type of machines in automatic lathes are also known as the magazine loaded automatics. Already we have discussed this because we have the automatic tool changer. In the automatic tool changer, or we have the automatic tool change arm. The automatic tool change arm. In case of that is a bright feature or the important feature of the machining centers, where we can accommodate from 48, 54 or 60 tools, different tools that are used in the machine shop for conducting different type of operations. Out of the 60 tools, some may be duplication may be there, because we don't only keep only one tool. We have to have a spare tool for the turning operation, spare tool for facing, spare tool for threading, boring, drilling, all the operations. So we have all that particular things. And according to the spindle position, already we have discussed how we can classify this particular horizontal and vertical. We have discussed in the turret type of lathe, horizontal turret and the vertical turret. Depends upon the spindle position. Spindle position is horizontal. We'll try to name them as horizontal machines. And this we have to choose the particular type of machine. If we are having jobs of smaller diameter, we'll try to opt for the horizontal machines or horizontal milling machines, horizontal the particular shaping machine, a horizontal this turret or horizontal. The mostly lathes are horizontal only. So only with special type of lathes we have the automatic lathes. You can have the vertical machines. So the spindle in the vertical position is known as the vertical machine, and they are used for heavier jobs. They are used for machining of heavier jobs, and these machines are more sturdy than the horizontal machines, because heavy duty machines, you can say, because they have to handle heavier jobs with a larger diameter. We can say shorter length also, because in some of the we have discussed in the turret lathes, the shorter ramp type, where the capstan lathe is also known as the short ramp type. So all this are there. So according to the number of spindles also, single spindle automatic and multi spindle automatic. So in the multi spindle automatic, all the particular spindles 2, 4, 6, 8 are arranged in a radial form, radial direction. So all this we can see in the diagrams. So single spindle automatics are, they operate on a single component, only single component at a time. But we'll just try to see the differences also later. But in the Swiss type, we have the classification of the single spindle automatic. They are further classified as Swiss type automatic screw machines and automatic screw machines. The Swiss type automatic machines are designed in Switzerland, and the automatic screw machines are also known as the bar type of turret lathe. They are known as the bar type. So all these are the things. So in the multi spindle automatics, so we'll just try to discuss now itself what is the difference between between the parallel action. The multi spindle automatic lathes are further classified into parallel action automatic and progressive action automatic. So parallel action type, the multi-spindles are arranged in parallel direction. The spindles are arranged in parallel direction. In the progressive type, what I told you, in the multi-spindle automatics, most of the multi-spindle automatics are progressive type only. That's why definitely the word will be on the tip of the tongue of any student or the faculty that the spindles are arranged in radial direction. But we have the parallel action type also. You have to know they arranged in parallel direction. So the same operations are performed on all the spindles in the case of a parallel action type. In the case of a progressive action type, we have different operations can be processed because we have number of spindles now. Different operations can be processed on each spindle, one after the other, one after the other. That is the unique feature of the progressive action type of multi-spindle automatic lathe. So the third one, you can say the rate of production is higher than the progressive type in parallel action type because the same operations are performed on all the spindles. But here in the case of a progressive action type, different operations can be processed on each spindle one after the other. That's why the time is taking, and the machining time, rate of production also will be less when compared to the parallel action type, but it is moderate when compared to the parallel action type. So the number of workpieces machined in the parallel action is equal because simultaneous operations are being performed. And here in each machining cycle, the number of workpieces machined are not equal to the number of machines. So all these are very important aspects of the differences between the parallel action type and the progressive action type. So here in the parallel action, if any problem occurs in one spindle, it does not affect the other spindles. It does not affect the other spindles, but it is not the case in the progressive action. Here, if there's any problem in any spindle, it affects the forthcoming spindles also, because the spindles are arranged in a radial direction. So that is the difference. So this particular parallel action type are engaged or they use for the small parts simple shapes. But in the progressive action, they are employed for complex shapes or complicated shapes for producing. That's why you have to choose the correct type of machine according to the design, according to the diagram. Ajad, can you hear me? Ajad? Chandrasekhar garu? You can hear me, Ajad?
Yes, sir.
Okay. In between, I'll ask because the current has come. I thought that the audio was unmuted, muted. Okay. So now you have a clear understanding of the parallel action and progressive type. So like that, we'll just try to discuss about the single spindle automatic lathe and multi-spindle automatic lathe after finishing this both the lathes. So this automatic cutting of machines are there. The basic construction is similar to the center lathe. So only I told you the other components are there like back shaft drive and the camshaft. All this are there. So we have the headstock, we have the tailstock, we have the front carriage, which is fed longitudinally, just like the center lathe towards the headstock. We have the front cross slide with the feed mechanisms, tool feed mechanisms, and cams are also there, but cams are not there fully automatic. Here in the semi-automatic, but we'll try to classify. Already we have classified for the longitudinal and the cross slide. So all these are very important, and we have the cross feeding also. So we have other drives for feeding, and we have the rapid travel units. Why I'm like rapid travel units? This I told you, whenever a tool is with a particular tool, the machining operations are finished for that particular, suppose turning or any other operation, it will come back to its original position. Or whenever you want to position the tool before the job, it's known as rapid positioning. G00 rapid positioning, G28 home position. All that you try to have. Suppose you are choosing some units also, you try to choose between G20 and 21, or you try to choose between G01 linear interpolation, straight line turning, G02 cyclic interpolation, circular interpolation, not straight turning. So all this we have G01, G02, G03. Suppose you want in between the rest, the G04 dwell period for machine setting, all this are there. So these machines are primarily used for this all the operations we have discussed earlier, and cutting off or parting operations also. So these machines are, we have the single spindle. Already I told you why you have to choose single spindle and multi spindle, a short length, because we have to go for mostly the cross feeding tools. So this particular work pieces are the power operated, not manual operated. Manual, okay, manual though no chuck is not operated by manually. The power operated between the centers. What are the centers? Headstock center and the livestock center. But here the live instead of the live center we have the turrets. So all this are there. So we'll just try to discuss all that. And these machines are have the definite power requirement for the definite servo motors power requirement from 5 horsepower to 35 horsepower, or 5 horsepower to 15, or for heavier we try to go as far as heavy duty automatics we have to go up to 35 horsepower. All this are discussed in some of the textbooks. So we have the next type. So before going to the next type, the Swiss type of automatic screw machine and the other things, we'll just try to discuss the differences between the particular differences between the automatic lathe and the semi-automatic lathe, and then we'll try to discuss the difference between single spindle automatic lathe and multi-spindle automatic lathe. Okay, so we have time. Okay, so automatic lathe, you know, all the operations are performed automatically related to the machining cycle. So the loading and unloading of blanks are also performed by the machine itself. But in the semi-automatic lathe, already I told you, loading and unloading are performed by the operator, by the machine operator. The second one, they are independent of the operator. Already we have seen in the features of the automatic lathe. And here the semi-automatic depends upon the operator. That is the second point. Third one, we have the overall time for a job is less. Overall time for machining cycle is less in an automatic. And in the case of a semi-automatic, we have already seen the overall time is more. Accuracy is high in the this one automatic machines. The accuracy is somewhat less when compared to the fully automatic, the automatic lathe. And the efficiency of the machine is more as far as the automatic machines are concerned. And as far as the efficiency in semi-automatic lathes is, when compared, is less than the initial cost. Because we are going for the automation, we have to invest, the management has to invest the lakhs or crores of rupees for the particular automatic lathes or the numerical control lathes, because already I told you, by implementing this automation, flexible automation or hard automation, we can increase the productivity by 800%. 800%. Suppose you cannot get 100% every time by using the ordinary lathes, the center lathe or engine lathe, but we can go up to 800%. That's why we have to go for automation. That's why we have to go for the flexible manufacturing system. So the less initial cost as far as the semi-automatic lathes are concerned. So we'll just try to go for the other differences later. The single spindle automatic and multi-spindle. Before going to that, the Swiss type, already I told you, these are developed in Switzerland, the design of the Swiss type of automatic screw machines. And these are used for mostly for the turning operations. Here, what are the things here? What is the unique feature? The headstock will be moving and the tool will be stationary. Instead of the tools moving and the job stationary, in the Swiss type, the headstock will be moving towards the tools. We have the front carriage with the tool on it. It moves towards the headstock. And this are the headstock will be carrying the spindle. You already know in the center lathe or engine lathe. And the longitudinal movement will be there along the machine bedways. So here the end of the particular linear stock or the job, it will protrude out. It will extend out of the chuck. Full extension will be there because you don't have to stop the machine in between and try to adjust the linear bar stock for a different operations to be performed on it. So you have to, it will be guided, the particular, how you try to protect the end of the bar stock is guided through a steady rest for the particular stocks. We have discussed in the lathe accessories, the steady rest and the follower rest. So all these particular machines are considered more suitable for machining slender jobs. Already I told you that slender, thin jobs with diameter from 2 mm to 25 mm. So all these are very important aspects. So wide variety of operations can be performed on these machines. So this is the Swiss type of machine. So it is somewhat complicated, but you try to opt for the different textbooks by drawing the line diagram. In one of the textbooks, we have the line diagram which comprising of the base, bedway, the headstock is shown in a definite fashion. Headstock will be moving towards the this tooling, and we have for the tooling we have the tool slide. Just you try to see that particular thing. Here it is somewhat the cutting zone, details of the cutting zone of this Swiss type are shown for the single spindle automatic screw machine. And the front tool side, we have the second one. This is the front tool side is the second one. And the rear tool side is the first one. This is operated by cam, because the tool slide movements are operated by the cam and rocker mechanism, both the combination. So most of these operations, that is the turning and the other operations, are done by the tools, which are mounted on the slides. What are the slides? This is known as the tool slide. Tool slides. The tool slide will be holding the tool, and we have the particular the cam and rocker arrangement for movement of the tools. Not only that, we have a guide bush also to guide the particular this whatever we can say, the tool carriage or the particular rocker in a definite fashion, in a not a zigzag fashion, in a definite fashion means in a definite direction. So we have the 3, 4, 5 are the vertical tool slides. 3, 4, 5 are the vertical tool slides. So vertical tool slides are mostly used for other operations, not conventional or frequent operations. They are used for undercutting, the parting operations, the cutting off operations. Parting or cutting off is one and the same. Chamfering operations to have to avoid the sharp corners, and nulling operations, just like because we have to have a grip on the particular instrument as far as a micrometer are concerned, or we have to have a grip on the workpiece as far as the definite design is concerned, to assemble that particular component, machine component, in a connecting rod, a big end connecting rod or a small end connecting rod, or the other IC engine components we have. So what is there's a difference between the Swiss type and automatic screw machine also. Already I told you this particular automatic screw machines are mostly used for manufacturing of screws, bolts, pins, etc. So the pins may be of cylindrical type, cylindrical cross section, straight cross section, or they may be tapered pins. So they are used for this particular things, the automatic screw machines. So this particular machines are capable of using different 10 types of tools for n number of operations. N number of operations, we have n number of tools. Suppose there are 10 tools, 10 operations. The 10 tools are mounted on the tool slide or on that particular turret, on the particular turret, this turret, or we can accommodate up to 14 tools, and we have the collet. We have the collets already, I told you, just like the holding for the definite different types of cross sections, this particular jobs, and the bar feeding mechanisms. Bar feeding mechanisms are automatic bar feeding mechanisms. They have the cross slide, already I told you, like a central lathe, or we have the turret slide for the turret. They are operated and mostly they controlled automatically by the particular different cam arrangements on the longitudinal as well as the cross slide. So this particular figure, this related figure, you can see as far as the automatic screw machine is concerned. So automatic screw machine is somewhat simple, but you try to mostly concentrate on the line diagrams. Now the 2D diagrams, not 3D. Just for the this particular arrangement is for tool holding of a turret of a single spindle automatic screw machine. So 6 tools can be mounted on the hexagonal turret. There's shown only the 6 tools, but you can replace the hexagonal turret with this turret. We can handle 14 tools, and suppose 14 operations are required. You try to arrange the tools in the numerical sequence. You try to arrange the tools starting from T01, T0, T110, T10, because numerical sequence, suppose as per the design of the component, as per the design of the job. So we have in this particular front tool slide, we have the chuck which is holding the workpiece, and the workpiece is rotating in an anti-clockwise direction. So all this simple diagrams which you have to practice. Only if it is simple, only practice. Manufacturing subject is consisting of lot of diagrams, because already I told you, as an examiner, if I am examiner, I'll give 50 to 60% for the diagram, and the rest for the presentation. Presentation should be good. So all these are definite things you have to see. So what is the difference between the single spindle automatic lathes? We'll just try to see after finishing this multi-spindle automatic machines. So multi-spindle automatic machines, already I told you, it consisting of 2 to 8 spindles. What are the features? We'll just try to discuss before going to the diagram. So these machines have the capacity to machine different diameter components. Different diameters can be machined. So, and most of the particular machines, this classification as per the multi-spindle automatic lathes are bar type and chucking type of machines. And the workpiece, suppose the workpiece is machined in stages. It is known as the progressive type, parallel action and progressive action, which we have discussed. So all these are definite things. So what is the example of this lathe? Example of the multi-spindle automatic lathe? It is nothing but it is the automatic bar machine. Automatic bar machine. So here the rate of production is high because the number of spindles are more. Already I told you 2 to 8 or 4 or 6 spindle machines are commonly available, and this particular bars will be loaded into the hollow spindles of the machine, and for each spindle we have the corresponding cross slide. For each spindle we have the corresponding cross slide, and the cross slide movement is controlled by the cams which are mounted on this cross slide. And whatever the rest of the operations of the machine are executed automatically, because until you finish that lengthier bar stock. So all these are definite characteristics or features of the multi-spindle automatic machines. So setting up this particular machines for a particular job will take a lot of time, but once the machine setting is over, you don't have to set the human operator intervention is less, and only unless the linear bar stock is over, you have to load the fresh bar stock or fresh workpiece. So here the machining accuracy is less because you have to index the spindles. Indexing should be done just like tool indexing or turret indexing. By bringing the spindle in front of the job or workpiece, that should be done, and we have a large number of fittings. Just like the mechanical comparator, we have a large number of moving parts. The accuracy is less, and the magnification is less. Here also, the multi-spindle automatic lathes will be having the less accuracy when compared to the single spindle automatic lathes. So that is the particular thing we have to discuss. So slowly we'll just try to see the 3 minutes, whatever we can discuss up to 12, but here you just try to see the multi-spindle automatic lathes. All the spindles are arranged in a radial form, 1, 2, 3, 4, 5, 6. So just try to see this particular diagram, and we have the corresponding cross rays. Already I told you, for each spindle, these are the spindles. For each spindle, we have the corresponding cross slides. For the first spindle, first cross slide, and here you just try to see the end of the tool slide. Here you just try to see the end of the tool slide is non-rotating. It should not rotate, because once the particular machining will start with the first spindle, it should end with the sixth one. That's why the end tool slide is non-rotating. So just try to see the direction of carrier rotation. Direction of carrier rotation is the anti-clockwise or counterclockwise. So this is the spindle carrier. You just try to see this is the spindle carrier, the bigger circle. So you have to draw this circle, the hidden circle. On the hidden circle, you have to mount the spindles. So at the corresponding spindle the workstation, you can say in computer aided manufacturing, you have the corresponding cross slide. How the cross slides movement can be controlled by the cam movement. So this is the working principle of this 6-spindle horizontal progressive action automatic machine. What do you mean by progressive action? Unless you complete the operation on the first spindle, you cannot go to the second spindle. So what is parallel action? All the operations can be performed simultaneously. That's why you take the machining time is more in the multi-spindle automatics than the single spindle automatics. That's why the rate of production is less in case of that's why the in single spindle, because you're using only a single spindle, the rate of production is low. Because you're using multi spindles, the rate of production is high. So there are many tool slides in the non-rotating, and because you cannot show all the 6 here, only we are just showing that particular tool slides, only a single tool slide. You just try to just observe the diagram also. So the total number of operations, suppose there are 10 number of operations, they're divided into a number of sets of operations, and all the particular operations are performed on each separate spindle. 6 operations, 6 spindles. Suppose 12 operations, the first spindle will be performing from the first spindle to the second spindle, the operations will be again a different set of operations will be done after finishing the first 6 set of operations. So all these are the complete machining can be done. A complete machining of a component as per the design can be performed in several stages, progressing from the first spindle to the 6th spindle. So this is a simple diagram of the multi-spindle automatic lathe. So Chandrasekhar garu, Azad.
Sir.
So we'll try to end this particular session now, and
Okay, sir.
we'll try to continue in the next class. Okay. Thank you for patient listening, all the students. Thank you.
Sir, number 1 birthday, sir.
Okay. I wish him many happy returns of the day, but this is an online class. But here I'm asking the particular recording. Sometimes recording is going off whenever current is off. Recording jarigindamma?
Yes, sir.
Okay. Thank you. Okay. I will end. Okay.
అతను క్లాస్ చెప్పి అతను